Hello, good morning. I am discussing about what are the types of CVD process. There are different types of CVD process: low pressure CVD, atmospheric pressure CVD, plasma enhanced CVD, photon induced CVD, metal organic CVD. 5 types of CVD process. First of all, atmospheric pressure chemical vapor diffusion. Atmospheric pressure CVD. It works at atmosphere pressure. It is used to deposit a layer of material, typically several micrometer sticks, onto a wafer or other types of substrate. It is also used as a surface finishing process for items such as tools and turbine blades to improve lifetime in performance. Since a vacuum system is not required, atmospheric pressure CVD systems have a relatively low operating cost. Atmospheric pressure CVD has inherently poor utilization. Atmospheric CVD is extremely susceptible to oxidation due to the greater gas density and residence times. Low pressure CVD. Low pressure CVD coating with excellent uniformity, high purity, and good step coverage. It works at subatmospheric pressure, reduce pressure, and to reduce unwanted gas-phase reactions and improve film uniformity across the wafer. The lower pressure increases the precursor diffusion through the gas, and mass transfer rate of the gaseous reactants becomes higher than the surface reaction rate. The pressure for low pressure CVD is usually around 10 to 1000 pascals, while standard atmospheric pressure is around 1 lakh pascal. Metal organic chemical vapor CVD, metal organic CVD. Metal organic compounds are used as molecular precursor, deposit a wide variety of thin film materials for new industrial application. The greater advantage of metal organic CVD precursors are their high volatility and moderate to low temperature. Therefore, reaction temperature are lower, 750 to 1100 Kelvin, than conventional CVD. The main advantages are the precursors tend to be very expensive and are very volatile. When reactive liquids are used, they require accurate pressure control and are difficult to purify. Laser chemical vapor deposition. Laser chemical vapor deposition uses focused laser beams to heat the substrate. It also has the ability to locally heat a part of the substrate while passing the reactant gas, thereby inducing the film diffusion by locally driving CVD reaction at the surface. It is used to deposit microscale solid patterns or three-dimensional structures on the surface of a substrate by a localized single-step process. Plasma-enhanced chemical vapor diffusion. Plasma-enhanced chemical vapor diffusion is used to deposit silicon dioxide, silicon, nitrogen, and silicon nitrogen oxygen complex amorphous silicon films. Plasma can be used to decompose a molecule that will not decompose at a reasonable elevated temperature. It can be used to decompose thermally unstable molecule, but at a much lower temperature. In plasma CVD, substrate that cannot tolerate high temperatures such as polymers can be used, where substrate temperatures range from 100 to 500 degrees Celsius. Disadvantage: chemical and safety hazards caused by the use of toxic, corrosive, flammable, and explosive precursor. Therefore, extra steps have to be taken in the handling of the precursor and the treatment of the reactor exhaust. High deposition temperature are often unsuitable for structures already fabricated on substrate. Restrictions on the kind of substrate that can be coated. It leads to stress in films deposited on materials with different thermal expansion coefficient, which can cause mechanical instabilities in the deposited films. Advantage: CVD films are generally quite, that is the ability of the film to uniformly coat topographically complex substrate, versatile any element or compound can be deposited. High purity can be obtained. High density, nearly 100% of the theoretical value. CVD films are harder than similar materials produced using the conventional ceramic fabrication process. Material formation well below the melting point. Economical in production since many parts can be coated at the same time. Application. Coating for a variety of applications such as wear resistance, corrosion resistance, high temperature protection, semiconductors and related device, integrated circuits, sensors, and optoelectronic device, fiber optics for telecommunication, used in the microelectronics industry to make fields serving as the dielectric conductors, passivation layers, oxidation barriers, and epitaxial layers. It is all about types of CVD process. Thanks for watching. Thank you for patience. That's now. Bye-bye. See you again.